how do you take the limit of this function as x approaches 0? Well, let's try direct substitution. What happens when x is at 0 or x is equal to 0? Well, immediately you should see that in the denominator, you're just going to get 0, so you're going to end up dividing by 0, and that's a problem. So that means direct substitution is not going to work. So what's the next thing we should try? Well, I know we have x squared, and you can't really factor x squared in any sort of way or reduce that. And similarly up here, we have an x squared, but we can't really factor or reduce that within the square root. But we have a square root, which means that we probably can rationalize this function to maybe make it a little bit easier. So let's go ahead and give that a shot. Okay, so I've rewritten our limit from up here down here, and I just put some brackets around our numerator to make it a little easier to see what we're going to do. So this is technically a rational function because the square root is in the top. However, I'm thinking maybe if we try and get rid of that square root and simply get this x squared to cancel with the x squared at the bottom, we won't be dividing by 0 anymore. So let's give that a shot. How do we rationalize this? Well, we're going to have to use the property that a squared minus b squared is equal to a minus b multiplied by a plus b. Now, when you're rationalizing something, you're actually on this side of the equal symbol. And what does it mean to be on this side? Well, it means you usually have either this or you have this. Now, in this case, it clearly looks like we have a minus b, right? We have something minus something. So that means our a ends up becoming the square root of x squared plus 9, and our b is actually going to be 3, not negative 3, because the negative comes from here. Okay, so that means we're going to want to multiply this by x, or a plus b, which is going to be this, right? That's what we're going to want to multiply it by. Now remember, when we're rationalizing, we're multiplying the whole function by 1 because we don't want to change the function. But we're not literally multiplying it by 1, we're multiplying it by f over f. And in this case, we found that this has to be our f, and it's going to be the square root of x squared plus 9 plus 3. That's going to equal to our f, like so. So let's go ahead and do that. Okay, so I've rewritten our top part and I left out the numerator. Why did I leave out the numerator? Well, we know when we're multiplying two fractions, the denominators multiply by each other, giving us this bottom expression down here. But in the top, because we're following this rule and we know what our a and b are, we can actually just use the quick strategy of, well, it's going to be simply the square root of x squared plus 9 squared. And when you're squaring a square root, the square root just goes away. So you end up getting in the top x squared plus 9. And of course, we're going to have to do minus all of this minus b, and b we know is going to be 3, and 3 squared is going to be equal to 9. Now we can actually ignore these brackets here, and we end up getting x squared plus 9 minus 9, plus 9 minus 9 is just going to be 0, so x squared minus 0 is just x squared, so we end up getting an expression that looks like this. And what do we know? We know that the x squared at the top and the x squared at the bottom cancel each other out, which is exactly what we wanted to do to no longer divide by 0. So we end up getting that they cancel, and it's going to be the same as saying the limit as x approaches 0 for 1 over the square root of x squared plus 9 plus 3. Now we can maybe try direct substitution. What happens when x is equal to 0? Well, that's going to mean that we have 1 over, well, x squared is going to be 0 squared. The square root of 0 squared plus 9 plus 3, which is going to equal to 1 over the square root of 9 plus 3, which is going to equal to 1 over 6. Now, because we didn't change the function at any point, we just multiplied this by 1, which led us to get an expression like this, which led us to directly substitute. That means that because this function equals 1 over 6 as x approaches 0, so does this function. This function, the limit here, is also equal to 1 over 6. So there we go.